Exercise 2. So to start this exercise, we're gonna copy the main file from exercise 1. So just to save a little bit of typing, and we paste it. So in this particular exercise, we're gonna cover a few things. We're gonna go over variables, placement groups, some other things. So let's start. So let me close the exercise 1 main file, and now we have the proper main file, main.tf. So let's begin with updating the Terraform version. I think right now is 287. I'm not positive on that one, so I need to, 287. So it's greater or equal than version 287. So with that, we proceed to provide a URM that stays the same. The IP address is going to stay the same. Okay, over here, this is going to be our first change. We're going to include a variable. So the syntax for that is $ squiggly bracket bar dot the name of the variable, resource underscore group. Yeah, that's it. Actually, let's do it this way. It's better. I don't need to do it if I'm not adding anything else. So right now, this is the best way to do it. Bar dot resource group. That's the way you call your variable. Now we need to declare it and then assign a value to it. So we create a new file. We're gonna call it variables.tf. And the first thing that we have to do is to declare the actual variable. So variable resource underscore group. Description. It's always a good idea to have a description of your variables so you know what they actually are. In our case, it's just a resource group. So type. This is quite important. This one is a string. You have different kinds of variables. You have a string, number, a list, and maps, as well as Boolean. That's the other one. So a string is basically a group of characters surrounded by a double quotes, which is our resource group in this case. So now that we declare it, we can proceed to actually assign a value to it. And we do that on a different file. So new file again. And this one is terraform.tf bars. That's the name of the file. Resource group equals, there you go, autocomplete, exercise -2, and that's a string. Okay, let's go to the next one. Location. This one can be a variable as well. So bar dot location, and we define it in the variables file. So variable location, description, Azure region. Type is going to be another string. location equals ES-US. Okay, let's continue. With virtual network, okay. In here, we're gonna use the variable, but this one, in this case, we are inside quotes, so it requires a special syntax to use the variable. So let's start working on it. So $, squiggly bracket, and a bar that resource underscore group. Yeah, that's the syntax. Resource group name stays the same, location, yeah, stays the same, no need to change that. Let me delete this because it's no longer exercise 1, it's going to be exercise 2 or whatever we have defined on our variables, actually on the Terraform TF bar file. Subnet, we do the same change in here. Dollar squiggly bracket bar dot resource underscore group, close your squiggly bracket. Subnet, that's fine. Resource group name is fine. Virtual network name is fine. Address prefixes, yeah, class C is fine. Public IP address. So dollar squiggly bar dot resource underscore group, close. The reason to use variables is because you can reuse the same module, and after that all you need to change is just your Terraform TF bars to whatever you want to name it. So it gives you that advantage that you can reuse the same Terraform code for multiple things instead of having to start all over again from scratch. Okay, that stays the same. Instead of just one VM, let's have more than one. Let's have two. So we're going, in order to do that, we're gonna use count. Count equals bar dot num VMs. So let me define this new variable, and then I go over what it is. Num VMs. Description, number of virtual machines. Type. Okay, over here we can introduce a new type of variable, which is number, and it's a number. So number VMs 1. We're gonna put 2, and it's also, let's introduce another little concept, default 1. Basically, if I don't declare that value on Terraform TF bars, it will use the default value, which is 1 in this case, but since I'm saying it's 2, it's gonna take precedence and whatever values on the Terraform TF bars. Okay, so what is going to happen in this section is it's going to create 2 public IP addresses that will be attached to two different virtual machines. That's how we do that. So we leave that. Don't worry about the alignment. We're gonna use Terraform format to fix that piece. So we don't need to be concerned too much about it. Now, name, bar, resource group, public IP address, that's fine. We need to make it unique. So in order to do that, $, squiggly bracket, count, that index. So each VM obtains one public IP address, and this is the way it's gonna know which VM is gonna get that particular IP address. Resource group name is fine, location is fine. It's gonna be static for now. Network interfaces. Okay, we need to use a count again because we need to create more than one right now. So count equals bar dot, yeah, number of VMs. The name, gonna replace it again with the same exercise 2, bar dot resource underscore group. Close it out. We need to make it differentiate which interface we're getting here. So dollar square bracket count that index. That's how you do that. IP configuration, that can stay the same. Well, needs to be exercise 2, so dollar squiggly bracket bar that resource underscore group. Subnet ID is the same. The public IP address that's going to be assigned, we need to use count in here. Count that index. Instead of a squiggly bracket, it is just brackets. So basically, this value, public underscore IP underscore address underscore ID, is going to come from here. ID is going to be created after this resource is completed on Terraform, but we're using the count that index, so it's going to start from 0. So one is going to have a 0, the other one is going to have a 1 when it's all created, all said and done. Security configuration, security group, SSH. That's good. Let's install Apache on those machines, just because. So let me copy this security rule. I think it's 11 lines. Yeah, it is 11 lines. So we're gonna name it HTTP. You probably should use TLS, but this is just an example, so we're gonna go with HTTP. Priority increases, has to be unique. It's gonna be inbound. Access is gonna be allowed. Protocol TCP. Source port range. Start, that's fine. The destination 80. This is our source address. The destination start, that's fine. Okay, let's carry on. Network interface, security group association. Stays the same. Well, not exactly the same. We have more network interfaces, so we have another one. So we're gonna use a count again in here. Equals bar dot number of VMs, and the interface ID is gonna have a square bracket count that index. Oops, let's undo that. Square bracket count that index. Okay, yeah, that works. That's this section stays the same. Yeah, that's it. In the future video we're gonna use a subnet association instead of the network interface. I think it's better, makes more sense for our exercise. something that we need to include anyway. Virtual machines, of course. We need to add counting here because we're creating 2 instead of 1. So count equals bar number of VMs. Exercise 1 is no longer valid. So dollar squiggly bracket bar dot resource underscore group. Close that. So group name is fine, location is fine, network interface IDs. Of course, we have more than 1. So this is how we differentiate index. Okay. Sites. We can use a variable in here. Yeah, we should. And we can introduce another kind of type of variable. So bar dot VM size. Yeah, that's fine. We want to make it a map, which is like a dictionary. Small. Yeah, why not? So let's define it. Our new variable VM size description equals virtual machine size, just to put something in there. Type is gonna be a map, this one. Provisioner. We're gonna look at those, but it doesn't belong in this section. Okay. VM size equals. We're gonna have a small. In my case, I'm gonna use I think D series for this one, but you should pick something even smaller, the cheapest one you can find. I mean, this is just for learning purposes. You don't need to overkill or do anything too expensive for this. I'm gonna use a standard D2 version 3. Specify another one, a medium. I won't be using medium, but just to show you how a map looks on Terraform. Standard L series L8S version 2. Extra, actually extra large, X large. I don't want to type that much, I guess. Standard L64S underscore B2. Hey, long line, but no need to be concerned about it. Terraform format will give it a nicer format. It will look better. Closing the open one. Okay, that's how a map looks. Basically, it's a key value pair. So small maps to standard D2 version 3 on our example right here. So that's a map or dictionary on Terraform. Admin name. Let's introduce another type of variable. So var underscore username. Autocomplete is not my friend. Yeah, I knew it. delete that. Yeah, perfect. Bar username. This is gonna make it a list. This is how you get elements from a list. So let me declare it and then assign a value to it, and we can go over how to retrieve values from it. Because in the dictionary you use the key in order to get the value. On a list you use the positional arguments in order to get those values from it. So let's go to the variables. Variable username. Description equals a list of users. Type is going to be list. And in Terraform tvars, username equals bracket Azure user, which is the default one on Azure. Put root in here, why not? Admin. We're not using any of this, just to show you how a list looks like. Okay, we have that. Disable password authentication true. Yep, we're gonna use keys. OS disk. For this one, we need to make it unique. We need to specify, assign it to a particular virtual machine. If we leave it the way it is right now, like let's replace exercise 1 so it's a little bit clearer. Bar resource underscore group. If we leave it like this, the second virtual machine won't be able to start, and our Terraform will fail because it's not unique enough. So in order to differentiate which disk belongs to which VM, we used count that index, and we use squiggly brackets because it's inside double quotes. Caching read and write, that's fine. Storage account type, we can use another variable just because, I mean, that's the main topic of this particular video. Bar storage account type. Yep, that works. And this one we can probably make it a list. Yeah, let's make it a list as well. So variable storage account type, storage underscore account type. Description equals it's just the storage account type. I mean, the variable name itself tells you, which is a good practice. I mean, try to use your variables as descriptive as possible. It helps with the documentation. A list. So storage account type is another list, and we can have in here standard LRS, and we can have premium LRS. Yep. So let's go back to storage account type. We're going to use the cheapest one, which is the first element, standard. Disk size in gigabytes. another variable var dot disk size. So variable disk size. For this one, it's going to be a number. Description disk size in GB. So type is number, makes more sense. Well, you cannot use one gigabyte. I think the smallest one is 30 gigs that you can create. So let's use 30 gigs for this example. I mean, you don't really need to declare it on your Terraform code, because if you don't specify, it's going to use the default value, which is 30, the smallest one. But just in case you want to have like 300 gigs or something like that, well, you can specify that on your Terraform code. Okay, that section is complete. We can probably use variables for the rest of this stuff. I'm not doing it right now, but you can. I mean, you can customize as much as possible from your Terraform. I mean, you can use a different publisher instead of Canonical for the Ubuntu. You can use a different Linux flavor instead of Ubuntu. Although with CentOS out, but you can still have some other alternatives, like probably Red Hat or something like that, and you can basically have variables for this. Okay, username. We can use our variable in here instead of this. Var that username is the first one. Public is fine. Public IP address, okay. Oh, this is the output, which is fine. For the output, we're going to do start that, because we want to get both IP addresses. If you happen to create more VMs, you want to see those as well, so we know where to connect to. Admin SSH key, okay, that's our public key. So we need to, I mentioned that we're going to install Apache, so we need to do a little bit of extra stuff. So the next section is connection. User equals var that user name. Host equals Azure RM underscore public underscore IP. That I think public IP, that's the name that I gave to that counter index, so it knows where to connect. That IP underscore address, yeah, that's it's basically the public IP. That's what we're getting, and we're telling Terraform to, okay, use this particular username to connect to this particular IP address using SSH protocol. We need to specify the private key that we're going to use to perform the authentication piece. So private underscore key equals file basically have it on my local SSH. ID underscore RSA. Now we're gonna use a provisioner file. Basically, we're going to copy a file. So source equals files index.html. We don't have any of that in our exercise 2, so let's navigate to exercise 2 and let's create that file. Let's create the directory files, and let's also create the actual file index.html. So going just to create a simple HTML document, really simple. HTML header, and then hello world. And now closing my header and closing the HTML tag. And we're going to send that to files index.html. Yeah. We look at it, files index. Yep. HTML. Ooh, missing the closing tag on that one. Yeah, syntax error. Perfect, now it's good. Okay, carry on. Now that we have our file in place, we need to specify the destination. Where are we going to put it? So destination equals home $, squiggly bracket bar that user name 0 and closing the squiggly. Perfect. Index.html. That's the place that we're going to put the file in the machine. Oh yeah, provisioner. Of course, this one is going to be a remote exec. Inline. So we're gonna type every single command that we're gonna run. That's what it does. So sudo apt update. That's the first command to update the repository entries. Second one is going to be sudo apt install Apache 2-y for non-interactive, and then sudo, we're going to move the index from line 131, the index HTML that we copied over. We're going to put it in the proper place so Apache can use it to display a web page. Username 0, index.html. Let me see. Yeah, looks correct. Actually, no. That looks correct. Yeah, the location. So it's var ww html. That's the location for the file. Oh, I need a comma here. Nor comma. And now just sudo systemctl start Apache 2. And yep, that's the last thing that we're going to do. For this kind of stuff, it's probably a better idea to use Ansible instead of the provisioner. There's nothing wrong with them, but it's probably better if you use Ansible because it's the appropriate tool, or something similar to Ansible. It doesn't need to be Ansible. In my case, I will use Ansible, but instead of trying to do everything with Terraform, it's probably a best practice if you use a different tool. I mean, use Terraform to provision all the resources, and for configuration you can use a tool similar to Ansible. Yeah, I think that's it for this video. Yeah, it should be it. Well, we need to save the files. Save all. Now that we saved them all, we can do Terraform init. Ooh. Type string location. Oh, I put it in quotes. Okay, that's silly. Yes, I put it in quotes. Oh, come on. Save all again. Terraform init. Okay, perfect. So 287. Ooh, 289. Okay, so we are on newer version. Terraform validate. Let's see what other mistakes I have in there. No mistakes, or no obvious mistakes. FMT. Okay, nice formatting. Terraform plan dash out equals tf plan. Let's wait for that to run. Okay, it ran. Perfect. We just need to apply it. So you just copy that and apply it. Let's sit in here until it creates everything that it needs to. Assuming that we don't have any further errors. Hopefully not. I mean, well, should have a couple of errors, probably next videos on purpose if I don't do it. So we can kind of troubleshoot. Creating virtual machines. Okay, no errors so far, and it's already creating the virtual machines 0 and 1 because it starts from 0. Creation complete after 3 seconds. Okay, it's copying the file. You can see it there. Okay, it's copying the SSH key. I saw an IP address. It's doing the update. Yes. Update, yes. Looks like it install Apache. Yeah, it is installing Apache. Okay. So it already has the file. All it needs to do is copy the file, well, and then start Apache. It's still installing Apache, 98%. Couple of sim links, and I have an error. Why? Oh, excellent. I know what is going on. I do have a typo. Well, no, it's not a typo. Is I need to differentiate these things. Already exist. Location. Here is the error. Basically, it created virtual machine 2, I think, already, and then try to do it again. Yeah, exercise 2 actually, because I didn't make it unique. So it's like, oh yeah, you have 2 virtual machines. You want to create 2 virtual machines, so let me go and do it again. And it's like, wait, it already exists, and that's the error that I got. But no biggies, we can always fix it. So it's dollar squiggly bracket count that index. This is actually a good thing because we got to troubleshoot. That's what this error means. That the element already exists, so you are trying to create it, but it's already there, so you want me to import it. That's the alternative that it gives you. It won't work, of course, because it's wrong. So let's save all again, and Terraform plan dash out equals df plan. And after this, we can just apply it, and we look out our HTML page, and with that we should be done. Hopefully the Terraform state didn't get corrupted because of the broken execution. If it got corrupted, we won't clean it up, but later on another video we're gonna troubleshoot that, how to fix those types of errors. When a certain resource gets corrupted on the state file, we can always remove that from the state file instead of having to delete everything and you lose all your work. Probably if something important you have in there, you don't want to delete it. You only want to remove the section that is causing the issue. You can do it through Terraform as well, but we're gonna do that later, not right now. Okay, should be creating the second virtual machine. And hopefully we won't get any more errors. If not, well, we troubleshoot them, but don't want to add more content than necessary in the video. I mean, it's a long video already. So it's installing Apache, creating sim links, man pages, a little bit of firewall stuff. Oh, 0, okay. Oh, didn't read the plan. So it probably removed one, which is the one that didn't have the index, the counter index specified into it. So it will create the two instances. Yeah, I need to check that out. I should have paid more attention to the plan, but I'm pretty sure it deleted that one because we removed it from our Terraform file. So it's no longer there. So it's gonna create two virtual machines instead of just one, which is fine. 100%. Okay, so it's doing the other instance. Yep, and installing Apache on the other instance. Excellent. Okay, it supposedly worked. Let's see if that's actually true. Do I have wget in here? Yes, I do. I probably should use curl instead of this, but it's fine. Oh, we have an index file, and there you go. That's it. Won't do it for the other one. I mean, you can go to navigate to your browser and see those IPs in there. I won't do it just because, I mean, it's an ugly looking HTML page. It's just an example. And with that, we are done. Happy terraforming.